Okay, let's see how you did. So find the exact value of the shortest distance from this point to this line. So the first thing is, remember that we have to know the other point of intersection, the other point, which is the point of intersection of the perpendicular lines. And in order to do that, we need to know the equation of both lines so we can solve the system. And in order to do that, we need to have the point and a slope. So we need to find out this slope and then take the negative reciprocal. So one is find slope and the perpendicular slope, which is the negative reciprocal. So let's do that here. So we've got 4x plus 3y plus 14 equals 0. 3y equals, bring everything else over, divide by 3. That's that slope, so our perpendicular slope is going to be positive 3 over 4. Then we're going to take slope and point and find the equation of the line. So we're going to find equation of the perpendicular line. So let's do that. So we've got y equals mx plus b. Y is negative 2. Slope is 3/4. X is 5 plus b. So we have negative 2 equals 15 over 4 plus b. And then we're going to bring this over. So minus 2 minus 15 over 4 equals b. That's minus 8 over 4 minus 15 over 4 equals b. So minus 8 and minus 15 is minus 23 over 4, and that's what b equals. Okay, so we found the equation of the line, which is y equals the slope, which is 3 over 4, x, and then our b. So now we have to solve the system. We have to solve this line and this line. So, this is in standard form. I think what I'm going to do is I'm going to put this in standard form, and then I'm going to add or subtract them. So let me just do this. If I multiply everything by 4, I'm going to have this. And if I bring everything over to this side, I will have a positive 3x minus 4y minus 23. So that is this equation in standard form. So now I've got this equation and this equation. So I'm going to now solve those two. So I have 4x plus 3y plus 14 equals 0. And I have 3x minus 4y minus 23 equals 0. And that's equation 1 and 2. Now I'm going to have to get my x coordinates or my y coordinates to be the same, and both require that I multiply both equations. It's not enough to just do one. So I'm going to multiply this by 3, this by 4, they'll both be 12. So equation 1 by 3 and equation 2 by 4, and they'll both be 12. So 3 times that is that, 3 times that is 9, and 3 times that is, what's that, 42, I think. 3 times 14 is 42. Okay, and that's a 0. Then I'm going to do 4 times this line, so that's 12. 4 times that is 16. And 4 times that, and again, if you need help, just do it here on the side. 2 carry the 1, that's 8 plus 1 is 9. 92. Okay, so now I have two new equations, 3 and 4, and I'm going to do 3 minus 4, because if I do plus, these don't eliminate, and I need them to eliminate. So 12x minus 12x is gone. 9 minus 16 is the same as 9 plus 16, which is 25y. And 42 minus is the same as plus. So that is for 134. And there we go. So now I have 25y equals 134. Y equals 134 over 25. Not a nice looking fraction. Nevertheless, that's what it's equal to. So no reducing possible, and now we're going to take this and we're going to sub it into, I don't know, I guess equation 1. Let's do that. So we've got here 4x plus 3y plus 14 equals 0. And then what we're going to do is we're going to rearrange, find out what x equals, and then we're going to have to put that point and this point in that long square root formula to find the distance between the 2 points and see what you get. So this question is going to end up being a crazy number, so I think we should leave it and move on. But I just want to make sure you know what to do, which is solve for x, then sub in that point, x, y, whatever it is, and this into the length or distance formula, and then you will get a number. Okay, let's take a look at this one. Find the exact distance from the point this to the line joining this. Okay, so the line that joins this has a slope of, oh, hold on, let me just go back here for a second. Find the slope, write the equation, and then solve the system. And then plug into that long square root length formula or distance formula. Okay, so here, just in case you wanted those steps, there they are. Now let's take a look at this. Find the exact distance from the point 7 rather to the line joining BC. So the line joining BC, here they gave us an equation for the line. Here they didn't even give us the equation, but they gave us enough information to find the equation. So let's find that equation. We need a point, have it. We need a slope, can get it. So let's do that. So the slope of BC is y2 minus y1 over x2 minus x1. And that's negative 3 minus 1 over 4 minus minus 2. And that's minus 4 over 6, which is equal to negative 2/3. Alrighty. Then we have a point. So the equation of our line is going to be, I'll do this, y minus y1 equals mx minus x1. And then I will have, I'll use this point, negative 2, 1, and this slope. So y minus 1 equals slope x minus minus 2. And then I'm going to minus 2x over 3 minus 4 over 3, multiply everything by 3, and then bring everything over here. Actually, it's getting a little short on paper. I'm going to go right here. Okay, so we have 3y minus 3 equals negative 2x minus 4. So I'll bring the 2x over. I already have the 3y here. I have this, and I'll bring this over. There we go. And now I just need to collect these. And I now have arrived at the point where I was where this question started. I still have all this ahead of me. So now that I have this line, I want to find the equation. I want to find the distance between this point and this line. So let's start. The slope of this line. So what is the slope of this line? All right. 3y equals minus 2x minus 1, y equals minus 2 over 3x minus 1/3. So the slope is negative 2/3, so the perpendicular slope is going to be positive 3 over 2. So there is the slope of the line that we want. There is the point that is on the line that's perpendicular. So now I'm going to do y equals 3 over 2 x plus b, and I'm going to plug in y is 7 and x is 5. And so I've got 7 equals 15 over 2 plus b. 7 minus 15 over 2 equals b. That's 14 over 2 minus 15 over 2 equals b. So that's negative a half. b equals minus a half. So now I've got an equation of a line. So I've got y equals 3 over 2x minus 1 over 2. So this line and this line, I need to see where they meet, these two lines. This is the line that was given, and I just found the equation of this line, so I'm going to solve them and see what that point is, and then I'll plug those 2 points into my distance formula. So let's see here. I've got this one and I've got this one. Okay, so you know what I'm going to do? I'm going to call this equation 1. I'm going to call this equation 2. And I'm going to sub this in for y. So instead of y equaling this, I'm going to say this equals this, because if y equals this and y equals this, they must equal each other, right? So let's see here. I've got 3 over 2x minus a half, and that equals minus 2 over 3x minus a third. To get rid of fractions, we multiply by the lowest common denominator, which of course is 6. So I'm going to multiply everything by 6. So what is 6 divided by 2 times 3? 6 divided by 2 is 3. 3 times 3 is 9. 6 divided by 2 is 3. 3 times 1 is 3. 6 divided by 3 is 2, and 2 times negative 2 is negative 4. 6 divided by 3 is 2, and 2 times negative 1 is negative 2. Alright, much nicer to deal with. So now I'm going to bring all the x's over here. And all the regular numbers over there, and that's 5x equals 1. So x equals 1/5. And then I'm going to sub it in to, oh gosh, I don't know. What should I sub it into? Why don't I sub it into 1? Why not? So now I've got y equals 3 over 2x minus a half. So now I have 3 over 10 minus a half. And if I want a common denominator, I'll have to make that over 10. So multiply by 5, multiply by 5. So that equals negative 2 over 10, or negative 1/5. So I have an x value of 1/5 and a y value of negative 1/5. And now I am finally going to, after all of this work, take this point, 1/5, negative 1/5, this point, 5, 7, and plug it into my distance formula and get a number, right? The big square root one. So as you can see, I've run out of space, but you can continue this on the paper that you're working on. And we are done with this chapter.